Now, would like you to also drink some water too. Well, he had the. Here, wait. You can drink some more tonight on us. All right. So we have a bunch of T-shirts. This one is in size large from Palo Alto Network. So it's large adult. So Security University, another one of our sponsors. That was a horrible throw. I'm not going to throw the next one. So again, I've been trying to give these away. The weather report yet again has changed in the last hour. I heard that it is not supposed to snow tonight, but I heard it is supposed to get below freezing, so it is going to be and raining. So therefore, there will be ice in your car in the morning. So who is driving in the morning? Where do you live, sir?
I live in Virginia.
All right, come get this. You're going to need this to come back tomorrow. So a nice Shmoocon ice scraper. It's not going to be Shmoocon without horrible weather. Wow, everybody loves the moose. You have a 10-year-old daughter? Yep. So I have primarily been giving these away to men who failed to remember that they should book their tickets after Valentine's Day to fly out to Shmoocon. I gave away the one to last time to a woman who forgot. So this time, again, a woman that forgot their significant other for Valentine's Day. Is there one in the audience? Say again? Well, then you don't have a significant other. You can have this and cuddle with it. You can cuddle with this soft moose. It's close enough. And so again, something near and dear to my heart. I have 1 billion children. So one of the things that we want to do at Shmoocon is teach the next generation to do what we do and hopefully be even better than we are. So the University of Washington put together an amazing card game to teach non-hackers about hacker technology, not just exploitation, but defense and reverse engineering and social engineering and all sorts of other really cool talks. This is actually a good card game. It's not just a bunch of hacker speak written on baseball cards. It's actually a good game. So, So I'm going to give this to the person who has the most kids. So let's start with 2. Does anybody? No, these are kids that you know of and claim. So and you have to have claimed them, not just. So 2. Your kid is here. All right, you win. Come up here. So I'm sorry, I'll change the rules because I can. So again, Control Hack from University of Washington, amazing card game. Please teach the next generation. All right, and the last thing I have, a Shmoocon ticket for the party tonight. Who is wearing the oldest Shmoocon t-shirt in the audience? Is anybody wearing a previous cons t-shirt in the audience? 2007. That's that. Okay, you win. Do you have one already? Do you have one already?
I got one.
Sorry, you in the back that's wearing one. You have one already. Well, I guess the people that are wearing Shmoocon shirts actually went and got a badge, a token into the ticket.
Wristband.
A wristband. Yeah, that thing. All right. I'm just going to give it to you all. Please give that out. So ask good questions. And not ask Siri good questions. All right, so without further ado, I'm going to introduce these 2 gentlemen. Please give them a warm welcome to Shmoocon 2013, and good luck.
I guess I'll start. I just got a text from my wife that says, kids that you know of, huh? So I guess she's watching online. Hi, honey, I was joking. Awkward. All right, phone's getting shut off. Sorry, honey. I love you too. All right, so yeah, you can take a picture of me beat red now too, huh? So let's talk a little bit about Chopshop, busting the ghost. You might be expecting a lot of Ghostbuster pictures, right? It's like tons of references to Ghostbusters. No, this is it, and it's Gh0st because ASCII art is way better than anything else we could find on Google Images and use legally. So let's play a little bit of audience interaction. Raise your hand if any of this sounds familiar and put it down when it stops sounding familiar. So you're responding to an incident. It's a lot of people, I imagine. A lot of us do defensive stuff. That's good. That's a good start. You find malware that talks on a network. I would imagine the same number of hands. Hopefully it didn't increase. That would be weird. So you have to ask yourself questions, right? At least I do when I'm in this scenario. I don't really do incident response, but when I hear about this is the kinds of questions I ask, right? So what happened? You know, who said what in this network traffic I'm looking at? Was any extra information stolen that I didn't know about? You can put your hands down, by the way. I'm done. Yeah. If you raise your hand through the entire thing, you can have one of these. So was any extra information stolen, right? All that kinds of stuff. Any additional malware was uploaded? Was there any unknown C2? Did they switch back doors and they're still on our network that we didn't know about? And there's all kinds of extra questions going on here. So if you have these questions, you have to answer them, and answers have to come from somewhere, so you need data. I personally believe that there are two main sources of data in any kind of incident response scenario. You can collect data from the hosts, right? That represents a little bit of scale problems. Lots of hosts. What data do you need from those hosts? Can those hosts be trusted? I don't know. I don't like deal with hosts. So there's one area of potential sources of data. The other potential area is collect data from the network. It is less of a scale problem. You usually have choke points in your network that you can monitor much easier as opposed to touching every single host. And I used to make the phrase, right, what's on the network doesn't lie. Has anyone here read Travis Goodspeed and all those guys? Do you have one? Okay. So I'm referencing the Packets and Packets paper. Has anyone here read that?
Those two guys raised their hands before.
Who?
The guy in the gray over there.
In the gray? Here.
You.
In the
collar.
In the collar. You right there, sir. Do you want this? Oh, can't go. All right. Do you know anyone who wants to go? Devin? Here. All right, I got another one to get rid of, whatever. So that particular paper, yes, it was for radios, but you know, it was, in my opinion, it was a really, really well done paper, and it made me rethink the what's on the network, you know, if you have it in packet capture, it doesn't lie kind of thing. So if you haven't read that paper, I would definitely highly recommend it. It's very good. So for us, we like network data, right? That's where I spend most of my time, is staring at packets and hex dumps, and that's what I love to do. So we're going to talk a little bit about network data. So what are we talking about when we talk about network data in this context, right? You're in an incident response scenario, you've got some traffic that you don't know what the hell's going on in it. We're actually talking about command and control analysis, right? We're talking about malware protocols. These malware protocols often change. They change in either very drastic ways or they change in very subtle ways. They will often hide in plain sight. There's a lot of HTTP-based malware. Does anyone want to tell me, speculate why there's a lot of HTTP-based malware? Yes?
Everybody loves HTTP out the fire.
There you go. That's it. HTTP gets you out of every network no matter what. There may be a proxy you have to be aware of. That's about it. When it comes to analyzing HTTP, we can talk about it later, but we have other code that we're not talking about in this talk, but it works very well with it, that we have released that works very well with Chopshop for analyzing HTTP. Ultimately, what we're talking about is you need to understand layer 7 traffic here. There's plenty of existing tools that do this. There's TCP dump, Wireshark, Vortex. There's a whole bunch of commercial tools. The Moloch guys are writing their own parsers, which is really cool. So all of these tools have different trade-offs. Has anyone actually written a line of code in TCP dump? I have. Anyone else? Yes? Yeah. Yeah, it's painful. So I'm apparently the only masochist in. Oh, I got another masochist with me. Yay. So, TCP dump is great for looking at packets. It's not so good for doing layer 7 session reassembly, and it's very cumbersome, very painful. Do not recommend it. Wireshark is another option, right? Anyone here use Wireshark? I don't have enough wristbands for you, but all right. So everyone's used Wireshark. Everyone loves Wireshark. Has anyone here written custom dissectors for it? Did you have fun, or did you want to like kill yourself? He's sort of, kind of, I sort of played on 495 for fun. Right? So, none of these tools are better than the other. They all have various trade-offs here. So Vortex, anyone use Vortex? I haven't used it. I've heard about it. You uses it. I was talking to someone the other day who uses it. It's a really cool idea. Basically, take an entire TCP session, dump it to disk, and then parse it, with some other tool that is just reading a file off of a disk, basically. And it gets rid of all of the layer 6 and below headers that you don't need when you only care about layer 7 information. So, and then there's a series of commercial tools that I'm not legally allowed to talk about here. So they all have different pros and cons to them. Some of them are good at something, some of them are bad at others. And for us, none of them really kind of did what we needed them to do, how we needed them to do it. Some of them, we could have jumped through enough hoops to make it work, but even I'm not willing to jump through that many hoops for some of these. So we actually went ahead and wrote our own, and we're going to call it Chopshop because, well, he wrote the core of it, and that's what he decided to name it. So Chopshop it is. It was initially like the
ISP or something?
yeah, I don't even know what that stood for. It was some series of letters someone came up with, and we had some stupid acronym to go with it, but he wrote it, so he called it Chopshop. So that's what it is. So what is Chopshop? It is our protocol analysis / decoding framework. It is entirely Python-based. There is a small bit of C code in the back end that no one ever sees, which we'll describe, mainly because we don't want to write our own network stack, so we took libnids and used that.
And we have before.
What's that?
We have written some of the network stuff before.
Yeah, you don't want to write your own session reassembly engine. Not fun. Yeah, one guy's laughing, going, yeah, you're right, that's not fun. So the entire thing is open, well, the core is open source. It's up on GitHub. We'll talk about that in a little bit. And the whole thing is meant to be modular and extensible. So you can actually, write your own decoder modules for it. So let's give a little bit of context of where Chopshop came from. Does everyone want to, if you can read that, does anyone want to tell me what that is? Hint, the answer's in the first line. So this is, so this is grep minus capital A 2 dash capital H for some function definition in all of the Python files in my current working directory, where all of the Python files are all of the decoders we had before. And the answer is there are 12 identical copies of the same function in 12 different files. And this is where we were at one point in time with our protocol decoders. So anyone here written software for a living? You probably want to shoot me right now for suggesting that you do this. I'm not suggesting you do this. This is a horrible, horrible idea. You change it in one file, now you have one version and 11 others, and it just turns into a maintenance nightmare. So here's another example of where we were that was bad at one point in time. These are two different base64 functions. There's the top one there that takes an S variable and then uses that to decode that S variable as a base64 string using a global alphabet variable. I don't know why whoever wrote this did it that way, but I want to shoot them. The bottom one actually takes an entire string and a alphabet parameter and decodes the entire string. So the first one, if you notice, only decodes a chunk of a string, so it's up to whoever calls this function to throw in many chunks. And the second one takes an entire string and decodes it and returns the entire decoded result. So you may be asking yourself, why are you writing your own base64 implementation? Why not just use the one Python has? Does anyone want to answer that for me? Yes? Custom alphabets. That man knows his malware. So lots of malware will base64 encode, not lots, some malware will base64 encode with a custom alphabet, which means you cannot use the standard Python base64 function. Yes? No, so the custom base64, well, all right, yeah, you could, so substitute your input string? Yeah, so that's a total hack, man. Just write your own base64. You're right. You are technically right, and it would work, and I would not hire you for doing that. I'm kidding. I'm totally kidding. It's a good hack. I had never thought of it. It is an honest to goodness good hack. normal base64 implementation, you're only allowed to substitute the last 2 characters on the end, that's it. So, the remaining 62 characters are set in stone unless you pull this clever hack that gentleman came up with. So here's the final example. I'm grepping for the start of a string, bytes equals, across 1 decoder. This is only 1 decoder. I changed the name for obvious reasons. I don't want to go telling you guys what decoders we have. And then I just generated the number of bytes in that line. There were 6,402 characters in this 1 line of code. It's kind of weird. So someone actually concatenated a bunch of TCP payloads into a string in our decoder. What does that mean? So I have this decoder for network traffic, except it doesn't actually deal with network traffic. When I saw this in one of our code repositories, oh my God, what are we doing? Why is this going on? So this is very much, horrible, horrible ideas. I'm not going to name who did it, because he might be watching online, and he'll fire me. So let's stop the insanity, right? We've been doing this kind of stuff far too long, and it was just a total nightmare to manage. So let's take some of these common things that we're doing and put them in libraries and just use them that way. So in Chopshop, there are 2 ways to address some of the answers, or some of the things I was just talking about. There is one base64 implementation. If you're wondering, it was the one on the bottom, the one that was actually relatively sane. And there is one way to get the packet time, so the timestamp of the current packet you're dealing with, from the core of Chopshop, or from the libraries in Chopshop. And you just import them and you use them. Like any sane software engineering person would tell you, stop reinventing the wheel. So there's one base64 implementation, there's a common timestamp, multiple packet time formats, excuse me. There's just a sample. So I said that there's one way to get them. There's actually many, depending upon if you want the date or the GMT time or what. But they are all essentially one function, right? And you only have to use this
one coming
once.
across the framework. So.
Yeah, there's one way to do this across the framework. If I catch anyone writing packet time functions and submitting them to GitHub, I'm not going to accept that pull request, sorry. So we actually took it one step further, and we noticed what a lot of people were doing with these timestamp functions is they would do things like, all right, get the current timestamp of the packet, take the decoded version of it, prepend the timestamp, print the entire string, right? Like they downloaded or they uploaded a new piece of malware to the victim machine at this time and print it to the screen. And they kept doing that over and over and over. It would be grab the timestamp, prepend it to an event string, print the event. And they kept doing it over and over and over, so we said that's crazy. Let's just provide one way to do this in the core, and you don't have to import anything. It's just part of the Chop library that every module can use. So with that, Murad's going to talk a little bit about the design goals and the API of the modules and everything like that, and then we'll probably, I think it's a demo after that.
Yep. So as mentioned over, there's some insanity going on here. So how do we stop the insanity? So first up, we had some design goals when designing Chopshop, and we had to make sure we adhered to this to make sure people would use it and whatnot. So first off, stop reinventing the wheel. Don't repeat yourself. Any of those other things you've heard, we'd want to espouse that sort of model and make sure people do not rewrite code over and over again. Keep it modular so that it can be used and modified in fun and nice, easy to work with ways. Standardize. Standardize not only on the way to use the framework, but standardize also on how analysts or writers of code work with the framework. Keep it simple to use. So it does not take the actual malware analyst to run the actual decoder you've written. That's pretty important because otherwise you're not going to get anybody actually using the framework. Keep it simple to write. Minimize, again, the amount of code they have to actually implement and write, so we've simplified things, made it easier to work with, reduced code, et cetera, et cetera. Share the core. This is actually really important because the secret sauce is in the modules, not in the framework. So you don't have to share any modules you don't want to share. And this is pretty important because if the core is open, you could always give it to a partner or something and give them your modules specifically to them and keep it kind of close to the vest if you want to. And this is what a lot of folks probably will be doing because you might be tipping your hand if you are looking at malware that you're seeing on your network and you're putting out the decoder for it on the internet. So we got our guidelines. We got to increase adoption. So how do we increase adoption? Let's pick a language that isn't really difficult. C is supposedly newbie friendly. I might disagree, but supposedly it's newbie unfriendly, so we decided to go with Python. And why Python? It's not just arbitrary, but we had a lot of decoders already written in Python, and we wanted to choose a TCP reassembler that was already written. We don't write our own because we've tried and it's not fun at all. So we decided that we'd be using pynids. Pynids is a Python extension to libnids. What it does is I think it's basically the 2.4 kernel of Linux, and it tries to reassemble packets, so get rid of out of order packets, so on and so forth. So what it does is, usually in a stream of traffic, you'll see, instead of those 5, you'll see just a stream of random data across it, completely intertwined, a bunch of duplicates, maybe some overlapping, maybe some dropped or whatever. This takes that information and separates it into distinct streams of data. So you'll have, in this case, 5, and they'll be cut up into 3 different types of sections. So you'll have the handshake, which is the three-way handshake, SYNAC, SYNAC. You have the data portion, which is actual data going back and forth, and you'll have the termination states like fin or reset or whatever. Okay, so we chose our method for working with packets and whatnot. What's the framework going to do? So first off, the framework is going to be split up into the core and modules. So the core should be doing most of the work for most of you guys who are going to be running modules. It's going to load the modules, it's going to reassemble the streams using pynids, hand the streams to the modules, process any information about the module that you shouldn't have to care about, and handle any bookkeeping that you might want to do in regards to the streams or the modules or anything else. You shouldn't have to worry about that, and so you don't have to. The modules, what are left to do? Process data. That's it, and profit. So what is a module? What is it made of? So there are a couple of things that are required and a couple of optional things. So first off, you need the module name. How else do you tell the user what module they're running? Some required functions, there's the init function, which is called, once Chopshop is started up, it gives your module a chance to do some initialization at the module level. Maybe you want to set some module variables, whatever. The taste function. The taste function is called after the three-way handshake is completed. And what it does is it gives you a chance to do some high-level filtering of the traffic you're seeing to make sure that you're not grabbing all traffic. Maybe your module only cares about port 80 traffic, so you can say, okay, I've gotten this source IP, this port, so on and so forth. It's port 80. I want to take it. I want to keep it. Handle stream. That data portion in the previous slide, this is where handle stream, this is where it's used. Handle stream will give you the chance to look at that data and do any decoding you might want to actually do. So the optional functions. So module info, this is the little blurb about what the module does. We probably should have made it required, but our naming convention is kind of weird. So module info tells any user how to use the module, flags you might take, etc. Teardown is called during the teardown states. It gives you a chance to finish up any stream information or stream type stuff. Say, for example, you're decoding some malware and it only can be decoded after the entire stream is completed. You could probably wait until the teardown and then decode it there. Shutdown.
Any malware that would do that. I was saying, I don't know of any malware that would do that,
I hope
but
not,
it's there for flexibility.
It's a possibility, so I just want to keep it in there. Shutdown is called when Chopshop is shutting down. It gives your module a last-minute chance to do some cleanup, do some stat tracking, whatever. So you'll notice that a couple of these modules take TCP data, and this is kind of important because that's what you're working with while you're making your module or your decoder. So what is TCP data? It's an object, a dictionary specifically, and it contains a few important elements. And this is the core of Chopshop for any developers or module developers who might be using this. The important stuff it contains, first off, there's the quad tuple. The source IP port, destination IP port, has the timestamp of the packet, has information about the client and the server, which I'll talk about in a bit, and information relative to the stream as seen by the specific module. So if you want to track any stats for that stream. It also has information about the module. So again, if you want to track stats for the module. Functions it contains, there's 2 functions. There's discard and there's stop. Discard tells the core that you're done with this many bytes from the stream, so it can do some memory cleanup and not crash. Which you actually shouldn't, but. Stop tells the core that you no longer want to handle the stream. So after you call stop, the core will no longer give you the stream to process. So once you think you no longer can decode it or something, just call stop, and it'll stop bugging you about it. So those client and server objects, what do they contain? There's 4 major elements that are in there, and these give you the window of your TCP session or the stream. So there's the data, the count, the offset, and the count new. With these 4 combined, you should be able to get a rolling window in the stream as it goes. So pynids is not like some other parsers in which it might buffer up the entire stream and give you it afterwards. It'll give it to you as it's going. which is nice because it gives more flexibility, which is one of the things we're going for. So using this, you can get a rolling window into the stream and figure out as you're going what you want to do. So now we have the data settled, the framework settled, and some other stuff settled. So how does a module actually work? What's the life of a module? Initialization is first, and this is required. Remember that init function? So you process your arguments, if there are any, and maybe you might want to set up module data if you have any module-specific elements that need to be set up for the lifetime of your module. Then you process data. Taste, as mentioned, is required. Again, it gives you a little chance to do some filtering, and also gives you a chance to set up any stream-specific information, like maybe a stack counter or something else, or maybe some dictionary or something for that stream.
Encryption, whatever.
Yeah, whatever. Handle stream, again, as mentioned, it gives you the chance to actually decode the traffic, and you get each packet as it comes in reassembled. Teardown, as the TCP session being torn down, you get a chance to do something. Shutdown. Shutdown, again, it's called when Chopshop is shutting down, and allows you to flush buffers, print stats, anything else you might want to do cleanup-wise, maybe print out files or something. So you figured out how to write a module, so you don't want to repeat yourself. Again, DRY, stop reinventing the wheel. So the library provides a bunch of things that make it easier for you to work with. So for one, as Wes mentioned, there's this chop library which we provide, which provides print functions, save file functions, and a bunch of other functions, so you don't have to worry about that. So when you want to save a file to disk, you just call the save file function, and it will figure out during runtime where the user wants it to be saved off. Instead of having to hard code locations, make it like weird flags or whatever, and try to figure that stuff out, don't worry about it. It's handled for you. There's a bunch of other things that the firmware provides to try and make things easier. Packet time functions, there's external libraries. So in case, if you notice that you're writing code more than once, take it out of the module, put it into the external libraries, then you can import it into multiple modules without having to repeat yourself. Yes? What?
How is this different from Twisted?
That was a different
How is it different from Python Twisted?
I haven't used Twisted, so I
Haven't
don't
used
know.
Twisted. I don't know. Can you tell me if it's different? Yeah. I don't know. I honestly couldn't answer that for you.
Oh, well.
Okay.
Okay, with that, let's actually try and decode a module. Wes will go over rats and how to actually bust the ghost.
Yeah. Oh, okay. My fine friend over here, Frank is his name. He just said that he's pretty sure that Twisted is for actually creating and writing protocols on the wire, not necessarily receiving and decoding as much. I have no idea if that's accurate or not. Yell at Frank if you disagree.
Throw a shmoocon.
Or throw a shmoo yes. So, what are we talking about here? Let's put this in further context, because now that we've kind of given the history of where Chopshop, where we were when we initially started writing Chopshop and some of the core ideas of Chopshop, let's kind of put this in further context by talking about rats. So, we're talking about remote access Trojans, remote access tools, whatever you want to call them.
Remote administration tools.
Remote administration tools is another name, back orifice, right? They're all in the same kind of family of things. Stuff that lands on a machine that gives you control of it in some way. So the key takeaway, if I had to pick one slide to really remember from this talk, it's probably this one. You can understand what a rat can do by reverse engineering it. You can reverse engineer the whole thing from beginning to end, and you can say it's got all this functionality. But when you're in an incident response scenario, that's nice to know, but you have no idea which pieces of it actually happened. You can understand what an operator of a rat did by decoding the protocol for your specific instance, right? And that's critical when you're doing incident response. A lot of people will, write reports on this kind of stuff and say, and then the malware ran netstat. No, what happened is an operator popped a shell and said, okay, now run netstat and give me the results. There's a key difference there. There is a human controlling this thing at the end. So don't confuse the actions taken by an operator with automated actions taken by malware. There's a critical difference there. So let's put it in further context. Man, I wish I had those extra bands. I shouldn't have given them away. It would have been so sweet here. I'll buy you a drink. How's that? Does anyone know what this is?
We have a band, apparently.
That was Gh0st was the header changed to Shmoocon.
Okay. Where'd this come from?
Brenton.
Oh, yeah, he's not going. He's got like a 2-year-old or something. Here, there you go. Oh, well, all right. So I'm going to not repeat what he said. Does anyone know what this is? Okay. I'll just carry on then. So how's that for a hint?
Anybody?
So if you can't read those bytes, they say shmoo in ASCII, SHM00. There are 5 of them.
Take a guess.
It's Gh0st rat, yay! The whole talk's on Gh0st. You want one? You good? All right, you got to come up here then. So let's give some further hints. So was it the 5 bytes that gave it away? All right, well, as you'll see in a minute, that may or may not necessarily be true for all Gh0st, but it's true for most Gh0st. So here's another hint. If you can tell what that is, that's 16000000 in network order. That is 22 decimal in host order. So notice the length of the TCP payload in this one packet is 22, and it has the length embedded in the at a particular offset. I'm not going to tell you what that offset is. We'll get to it in a minute. And then finally, probably the dead giveaway. Man, I should have come up with another one here. Does anyone know what the zlib header is?
789C.
All right, that guy got it again. I was having drinks with you last night. So yeah, 789C is the zlib header, and it's at a very specific offset, especially relative to the previous D word I was talking about here. So that is the zlib header. So that's another dead giveaway that we're talking about Gh0st. So what is Gh0st, right? I used to call it open source malware. I changed it because it's not open source. It's actually leak source. It's not like you can go to GitHub and grab your latest GPL copy of Gh0st. But it is so unbelievably widely used and widely known that if you search for Gh0st rat on Google, there's like 30-something thousand hits there. AV companies love to write about this thing. It's apparently like one of the few rats that they love. It is actually attributed to a Chinese hacking group, but it is leak source, so whatever version is being used against you may or may not be used by the Chinese. I'm not trying to attribute anything here. The original version has been attributed to a Chinese hacking group here. And it does make a great example for this talk because let's be honest here, right? If your malware is on Wikipedia, there's nothing secret about your malware, right? It's not like we're talking about some crazy new malware that's attacking only certain industries that no one else in the world has seen. It's on Wikipedia, right? Get over it. So some AV companies that have written about this thing, and I'm not going to tell you these papers are good or bad, but you can certainly use them to go read up on Gh0st if you want. There's the RSA VOHO campaign, there's the McAfee Know Your Digital Enemy, the Gh0st one. There's the Norman ASA paper, which does a lot of good clustering analysis of Gh0st. So if you're interested, you can certainly always go read those papers. I'll have links to them at the end here. So let's dive into the Gh0st protocol in a little bit more detail. So this is your typical Gh0st header. You have a flag, which is usually 5 bytes. The default is Gh0st with a 0 and a capital G, but the public literature talks about lurk 0, heart, and they talk about a couple others. There's just 5 bytes at the beginning. That gentleman over there noticed that all 5 bytes were shmoo. So yes, I did change the package to say shmoo because I wanted to be clever and have it not say Gh0st. That would have been a little bit too easy. They are usually human readable. They don't necessarily always have to be, but most of the people that are modifying the Gh0st rat, just because the ones that are there say Gh0st or heart or whatever, so they just put some human readable string in their place instead of unprintable bytes. So following the flag is a D word for the compressed length. That is the compressed length of the entire message. It can span multiple TCP packets. In fact, many of them do. The good news is that login packets almost never do unless you're on like a less than 300 byte MTU link or something, which no one in the world is on that. Following the compressed length D word is the uncompressed D word length. So that is, the total size of the message when it's uncompressed. Then you have your zlib header, that's a 789C, and then you have your zlib compressed data. So any questions on the Gh0st protocol? Because it's kind of critical if you want to talk about decoding Gh0st. You have to understand this header. We're good? All right. I can't see anyone over there, by the way, so you're going to have to shout if you want a question.
Or throw a shmoo ball.
Or, yeah, throw a shmoo ball. So let's talk about decoding Gh0st in a little bit. So the goal, if you want to decode Gh0st, lots of decoders, in fact, our initial version that we put on GitHub did this. They just simply said, all right, if the first 5 bytes are Gh0st or heart or lurk 0, and we just had this like massive regex statement that was just looking for all of our known flags. It's hardly something that you want to do because every time you get a new variant of Gh0st with a different flag, you got to go update your decoder. So we have a different way of doing it. So our goal here is to figure out the size of the message that we need to decode first. So if you want to figure out the size of the message that you want to decode, you can always just go ahead and say, all right, well, it's going to be 5 bytes for the flag plus, sorry, it's always going to be 5 bytes for the flag, so just jump 5 bytes in and look for a D word there. And if that D word matches the length of the packet, maybe Gh0st, it's a good chance it's Gh0st, maybe. But you can actually do better than that because the flag doesn't always have to be 5 bytes, just what everyone tends to use. So all it takes is someone to deploy Gh0st on your network with a 4-byte header and your decoder just busted. So our approach to it is we're going to search every D word in the first n bytes of a stream. So I think by default n is 20.
20, I think.
Yeah, completely arbitrary, you can change it. But I thought 20 was a good number. So we search the first D word in the first n bytes of a stream. So by that I mean we search bytes 0, 1, 2, and 3. If it matches the length, then we move on. Then if it doesn't match the length, we check bytes 1, 2, 3, and 4. So we drop 1 byte off the end and add 1 in the other direction, or on the other
Basically
side.
rolls down
Yep.
the stream.
So and if at any point that matches the length of the current packet, we then jump past that D word and look for the zlib header, right? So we assume, all right, these 4 bytes are the compressed length, let's jump another D word past that, so we're skipping the uncompressed length and looking for a zlib header. So if we find a zlib header there, that's a pretty good chance that we have Gh0st. So now at that point we can go back to the length D word, and everything before that is the flag. So if it's 4 bytes or it's 6 bytes, we'd find it, as long as it's within the 20 bytes. And that 20 is configurable, so you know, we just picked 20 because who's going to have like a 21 byte Gh0st flag? That's crazy. Now, there's some malware guy like, I'm going to get you. I'm going to put a 21 byte flag in my malware.
Yeah, but it is hard-coded, so they have to change every instance to match the size, because to change the size, it's 5 by default, and they check that size.
Right, yeah. So the reason it's almost always 5 is you got to change a little bit more in the malware than just those 5 bytes. They have like offsets that you got to calculate and
Programmers are
stuff.
lazy.
So that's why 5 usually works, but in case it ever changes, our Gh0st decoder is somewhat future-proof here. So that is effectively detecting a Gh0st header. I haven't necessarily talked about decoding Gh0st yet. Any questions on that? All right. All of them that I've seen, yes. As long as I should also probably mention the zlib portion is technically optional, although just about everybody uses zlib because it shipped in the every version of Gh0st source that I've seen.
So after this talk, no.
Yeah, after this talk, everyone's going to turn off zlib, so. Okay, that makes it easier, thank you. Yeah, this works for, whatever the flag is, any 5 bytes, 4 bytes, 6 bytes, anything within that sliding window that we deal with, it should work. With one exception, which is what I'll get to in a little bit. So now that we found the Gh0st header, we now have to decode the entire Gh0st message that we now know the compressed length and the uncompressed length for. So literally what we do is we buffer up the entire thing, we throw away the header, and we collect that only the kind of purple portion, right? I think we saved the zlib header because zlib, I think, requires it and like yells at you if you try to unzlib something, uncompress something without a zlib header. So we buffer up like the purple and the orange part, I think. I could be wrong about that. And we decompress it. And what you're left with when you decompress it is effectively a 1-byte token and a bunch of data afterwards. And that 1-byte token is kind of like, hey, I'm sending you a login packet, or hey, I'm sending you a give me your drive listing packet, right? Or hey, I'm responding with this. I believe the way it works is the operator sends tokens and the malware responds with commands. It could be backwards. I don't remember, but effectively there's 1 byte that kind of says this is the kind of message we're dealing with, and then there's data, and that data is essentially dependent upon what that token is. So login packets, login data looks different from file management data, looks different from key logging data, et cetera. So what you need to do is you take that 1-byte token and then you decode the rest of the data based upon what that is. And then you profit. So it works for all the Gh0sts that I've seen, with the exception of the things that aren't actually Gh0st. The problem with Gh0st is anyone can modify it, and then it's not Gh0st anymore. It's their own little variant of Gh0st. So there are, because the source is available, there are an infinite number of variants. So the ways you can screw up our Gh0st decoder right now is not having a zlib header. We do assume that there is a zlib header. Another way to do it is insert a new command. So they literally have like command 1 is this, command 2 is that, command 3 is this, and then command 4 is this. If you change command 4 to be something else, and you don't update, and the decoder isn't updated to reflect that, we will assume it is the old command and try to parse it as such. So ultimately, your mileage may vary in the wild with this, right? There are plenty of weird variants of Gh0st, so you still need to RE the malware. You still need to know what the commands and tokens are and make sure that they're accurate to what the decoder is expecting. Or you can just run the thing, and if it crashes, then you know it's not really Gh0st.
But once you do RE it, you can just write the module in Chopshop and then use that over and over
Yeah,
again.
you can just extend our Gh0st module and say, all right, command 4 is no longer what we thought it is, it's this new one, and so you just write your quick function there and you're done. All right, so I think it's demo time now.
It is, that's how it works.
I'm going to pray it works.
I take this.
So Murad's going to help me demo this because he wrote most of the web end, or all of the web end. All right, so I should have, so what you're seeing here is
not
a horribly busted Windows 7 machine. Oh, you're not seeing it. Good, because it's busted. This isn't good.
VM broke?
I don't know. I'll show it in a minute and everyone will laugh and they'll be like, ah, your VM sucks. All right, so here we go, mirrored. Thank you. Go away. All right, I can't make that window go away, so I'll just make it go down there. I don't know what the hell just happened here. That's not good. Pause.
The victim machine?
No, so this is like, this is the operator machine. Yeah, that's not good. Come on, video driver, reload. All right, while that's going on, so I'm going to quickly just kind of talk about what we have here. We have a victim machine and a evil operator machine. I'll explain those asterisks in a minute.
And the operator means remote administrator.
Yeah. Evil operator, I mean the guy on the other end being evil. And then in the middle we have Chopshop just kind of listening live on the wire. I do not recommend that you run Chopshop on any kind of even remotely saturated link, even like, you know, a 100 megabit link.
But it looks awesome, so.
Yeah, we're doing it live because it's a cool sexy factor. You probably just want to capture your data and then read it off of disk later. You know, it's probably forensically sound to do that. Oh man, this sucks. What is this? What is this scroll bar?
Graphics driver crash or something?
All right. Oh, sweet, it's working.
Minimize it and.
Woo! Wait a minute. Notepad.
What are you doing?
So if you can't tell, I can't operate a computer. Woo! All right. So this is our evil victim machine. In the middle is another machine that I'm not going to show you. It's just a regular old Unix box.
The operator.
Sorry, yeah, this is the operator, not the victim. In the middle is another old Unix box, just kind of acting as a router between them. You know, normally you'd probably catch this off of a tap and capture it and then read it in later. So over here is a Windows XP box, which I'm going to boot. And while it boots, I'm going to explain the, let me explain this before you do your thing. So you may have noticed the asterisks next to these. That is, the terms are slightly different, right? Generally, you don't consider a victim laptop a server. In the malware world, it makes sense because you send commands to a server, and that is what this malware does. I'm sending you a download, you know, steal this file for me command or execute this shellcode type of command for me. So that's why client and server are often reversed in the malware world. So, all right, so I'm going to,
Before we log in.
yeah, we got to do this part.
So this is Chop Web. This is a new interface we made for 3.0 beta, which probably is an arbitrary version number. It's supposedly friendlier, easier to use. I was typing in help to show what commands are available. And right now, nothing is instantiated, so you didn't want to instantiate a new instance. Type in new. And now you can get all to see the current settings. For this demo, we're probably going to only set two things, which is the interface and the module. So set the interface to, what was it, EN? Oh, please close to the mic. Can you hear me now?
Slow down.
Okay.
All right.
Not in a New York minute.
So he's saying you can generate a new choplib instance. You can use get all to see all the current parameters, and then you can set your parameters by doing set
Set interface. Was it EM0 or
EM0, yeah.
And then he wants to set the module to our Gh0st underscore decode
So I screw this up. Is it plural modules or
modules.
not?
You
Modules.
also
All
can
right.
see it in the get.
Ah, look at that. Gh0st decode dash V.
Yeah, dash
V is just for verbose.
Verbose.
There's other options, like if you want to increase the size of that 20 bytes in the beginning, you can. I don't remember what the option is, but you can.
I think the module help one works if you want to try that out.
Oh, really? All right. What is it? Module help?
I don't know, do help and then find out what it is.
All right.
That's the point.
Ah, thank you. Thank you. Go away. Help. List params. Maybe we haven't implemented that. Anyways, carry on.
I did, but maybe an older version,
Yeah,
whatever.
I might have an older version.
Once you start it up or get all the parameters going, you can type run to run it.
Okay.
What are you doing?
No, so this is telling me, hey, I need to actually start sniffing now for some reason. I could have sworn it was sniffing already, but whatever.
So Chopshop opens up windows in the back, and each one is for the framework and then each decoder you're running. So if we're running multiple decoders, say Gh0st and I think we have payloads in the GitHub version.
We got a handful of decoders.
Yeah, so
I'll talk about
each of them
in a
will get
minute.
their own window.
Yep. So you can run multiple decoders on your traffic. If you have 2 different malware sessions in one PCAP file, you can just do, set modules, foo, comma, or semicolon bar, and it will put 2 different tabs for you,
So switch to the Gh0st decode module. Right now there shouldn't be anything unless it beaconed out.
which it hasn't, because you need to log in. So I'm just going to be like regular old Gh0st, logging in for the day at work. He's going to do his work, and apparently some customer survey is going to run on the box, whatever the hell that is. Remind me later, I don't know. I don't know what that was. All right, so you can see over here on the left, it logged in, right? So this is, I'm evil operator guy, right? And ooh, look, someone that I infected with Gh0st has shown up. Oh, we totally broke. We totally
You
broke.
missed the initial packets or something.
Oh, it logged in before I started it? Bummer. So I don't know how to get Gh0st to restart, so we're just going to restart the box. Are there any questions on it? Why doesn't it work? It works because I suck.
Just breaking everything, aren't you?
I'm just going to do a jig here, dance, da-da-da. Question. Yes? We support UDP. We're only talking TCP here, but we do support UDP. The data structures are slightly different, but we do support it. Any other questions? Yes?
Does your Gh0st module attempt to support multiple variants, or do you have multiple modules?
So ours is generic somewhat.
Ours is generic in the sense that, so do we support multiple Gh0st variants? Ours is generic enough that we don't care what the flag is. So if your definition of variant is they changed the flag, we're fine. We support them all. If your definition of variant is they injected a new command in the middle of the enum, nah, we don't handle that. So, but we can easily handle it if you want.
Is it all the TCP level, or can you parse HTTP and actually have it?
So we can talk about that in a little bit after the demo, but yes.
Well, if the framework handles TCP and UDP, but there are other things that can handle HTTP and
You can write your own HTTP parser in Chopshop. In fact, we did it and released it.
It's also in the GitHub, which we'll give a link to eventually,
Okay, so as soon as this shows up here on the evil side, you should see something here in the middle.
if nothing else breaks.
If nothing works, I'm just going to give up. And I can promise you it'll work. It usually, so the problem with Gh0st is, right, they have a delay timer. When you log in, Gh0st doesn't necessarily kick off right away, so now I got to fill time. And hope it shows up.
Does anyone visit Hack Fortress today? No?
No, no one did hack
Seriously,
Fortress?
no one? Woo. Okay,
Awkward.
seriously.
Okay. Should run. I'm praying it runs, or I'm going to look stupid. It ran like 20 minutes ago, I swear.
Demos always break, right?
All right,
If I got a machine infected with Gh0st they want to give us? No?
there it is. Woohoo! Yay! All right, I feel much, much better. Okay, so let's go ahead and look at what we got here.
Put it in Zen mode.
No, I don't know if I have the Zen. Oh, I do have the Zen mode feature. We totally stole it from GitHub.
Well, the code's completely written by me, but
Yeah.
the concept is stolen from them.
That just allows you to full screen it. It's like his favorite feature of all time, apparently.
It's pretty.
So what we're looking at here is a Gh0st login packet. So these are the kinds of things you can get out of it. So when we went through the whole find the Gh0st header, find the compressed length, all that business, and then decode based upon what the initial 1 byte value is, this one happened to be a login packet. And we can get things like the Windows version, the build, the clock speed, whether or not there's a webcam. Gh0st supports turning on and off webcams, supports turning on and off microphones. We do support telling you that they are doing that, but we haven't gotten around to writing the, okay, let's take the video and save it to disk portion yet, mainly because I don't want to write that. So let's I have a cheat sheet here because,
Or anybody know Chinese?
yeah, if you know Chinese, you can tell me what that says. Awesome. Otherwise, I have a cheat sheet somewhere. Here it is. Yeah.
Because there are hotkeys we can use, so.
Yeah, but I got to know what the hotkey means. So like F is file management, C is screen spying, K is keyboard, right? So let's turn on the keyboard logger. And let's go over here and do start, run, command. Oh, no, it doesn't work in the command prompt. It works in
Notepad?
Notepad. So you can see, right, the Gh0st controller is seeing exactly what I'm typing, super secret password. And you can see down here, so this is all per message, so they don't necessarily buffer an entire keylog thing, but super secret password, right? So kind of cool. It does plenty of other things, so I think T is for shell. T is terminal, I guess. So you can see, right, they pop up a shell, cd/dir.
We'll do the GUI browse the file system thing.
I'll do that in a second, but in real time, if we want, we can watch what these people are doing on our networks. So the other part of it, right, let's say they want to upload a new piece of malware, if my right mouse button will work. F is for, I'm going to guess file manager, because I tried it and that's what happened. So you can see over here in the Gh0st window, you can see,
The initial listing of the
yep, drive
drives.
listings. So the top one is the Windows 7 machine, the bottom one is the victim. So I'm going to browse around on my Windows 7 machine, see users, W shields, because I'm apparently the evil operator. Desktop. So let's say I want to, on a victim machine, I want to go to their C drive and upload a new piece of malware. I'm just going to upload a text file, whatever. It's as simple as just dragging and dropping. And you can see over here, file size is 21 bytes. Here's the data packet. So if you wanted to, you could actually save this thing to disk. So if they are uploading new malware, you can get a copy of it. That's really all I kind of wanted to show. You can go read the source code if you want to see exactly how we're doing it. But this gives you real-time visibility into what's happening on your network during an intrusion, provided you have a decoder for that particular malware. And thank God the demo worked. That would have been horrible. All right. What's that? Yeah, we got like a couple more slides and then we'll carry on. All right, so Murad's going to talk a little bit about Chopshop and its high-level design and how you can use it to embed it in other programs.
Yeah, so with 3.0, we decided to cut apart the different sections so it'd be easier to integrate with other projects if you want to. So there's I guess a tripart design, as you can see there. That's the Chopshop design. What you saw was ChopWeb, which was actually done as a proof of concept to show that you could use it in a different way. So the bottom right is the Chop library, the main thing you import and use. And then the Chopshop program is the main thing that you interact with on the command line. ChopWeb is in its place in this model we showed you there. And so it should be easier to work with 3.0 beta. So you can integrate with any project you might be interested in and extend it yourself if you want to.
So as he was hinting, we have Chopshop and we have ChopWeb. We were showing ChopWeb. If you just want a command line version and just scroll around in your terminal, that would just be Chopshop. Yeah. Time, I'm done.
Oh yeah.
Holy
10 minutes
crap.
before.
All right, so we're going to skip why Chopshop because I think we presented our case. You can get it at GitHub, and you can, the second URL is where we talk about some of the modules we've written. You can create your own decoders, you can contribute them back. There's some URLs, and that's our logo. If anyone has graphic skills, that's Chopshop Rod 13. We'd like a new logo, so we'll take that. That's it. Apparently they finished at 10 minutes.